Okay, so three terms that you need to know. First term is angular displacement. So look at this bicycle wheel right here. You got this bicycle wheel. If we take a point on this wheel, if this point goes around one time, that would be an angular displacement of, we could say, 1 revolution, or we could say 360 degrees, or lastly, we could say 2 pi radian. So there's three possible ways to measure an angular displacement. Got it? What if the wheel went around twice? What if it started here and went 1, 2? Then it would be what? 2 revolution, 720, or 4 pi radians. All right, angular velocity. If you take the angular velocity, if you take the angular displacement and divide by the time, then you have angular velocity. Okay? So for example, let's say that this wheel spins around 10 times, so 10 revolutions, and say that that takes place in a period of 5 seconds. So what would the angular velocity be here? 2 revolutions per second, which you could also express. So how else could you express an angular velocity? Instead of 2 revolutions per second, you could say 720 degrees per second. Or what else could you say? 4 pi radian per second. You guys with me? Not too hard. You take the angular displacement, divide by the time, that gives angular velocity. All right, then lastly, angular acceleration. If you take the change in the angular velocity and divide by the time, then you have angular acceleration. So let me demonstrate an angular acceleration. So I have this bicycle wheel right here. What's the initial angular velocity of the bicycle wheel? 0. So ready for an angular acceleration? Faster, faster, faster. Good. All right, so you get the idea. If something is going faster, 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 if it's speeding up in an angular sense, that's referred to as an angular acceleration. Any change in angular velocity is going to be angular acceleration. Now, what will the units be for angular acceleration? Well, what's this measured in? Angular velocity is measured in revolutions per second. Divide by seconds. What does this give us? Revolutions per second squared, or you can change the revolutions to degrees. So it could be degrees per second squared, or you could change that to radians. So there's 3 possibilities. It could be revolutions per second squared. It could be degrees per second squared, or radians per second squared. Okay? All right, the rotational kinematics. Okay, guys, you do not have 4 new equations to memorize. The thing I want you to see is that these rotational kinematics are the same equations as the regular linear kinematics. All that's happening here is that linear displacement becomes angular displacement. Linear velocity becomes angular velocity, and linear acceleration becomes angular acceleration. Okay? So basically, just put the word angular in front of it. And these rotational symbols are different than the linear symbols, which I think you probably recognized already. But the equations are the same. Does everybody see that? They're the exact same equations. Okay. All right. Now, final screen, and then we're done. So we have 2 equations for tangential velocity. Let's quickly review what tangential velocity is. So here's a bicycle wheel, and say this bicycle just rode through the mud, and say there's a speck of mud right there on the bicycle. Now, the wheel is rotating the wheel is rotating this way. If this speck of dirt flew off the wheel, how would it leave the circular path? It would leave how? Tangent to the circle, like that. Okay, what if the speck of dirt were like right here? How would it leave the circular path? Tangent, like that. Okay, now, if you don't have this written down, you should write it down. Tangential velocity, what do we measure it in? It's measured in what? Meters per second. It's a linear velocity. It's not an angular velocity. It's a linear velocity. Okay, here are two equations to calculate tangential velocity. Now the first equation says this. If you want the tangential velocity for an object traveling in a circular path, what you do is you take the, what's this? That's the angular velocity, and you multiply by r, which is the radius, the distance from the center. Now, angular velocity, very important. This must be in radians per second. You have to be in radians here. Now, does that mean you have to put your calculator into radian mode? No. Leave your calculators in degree mode when you're in this class. But when you plug into that first equation, the angular velocity has to be in radians. Now, there's something else you have to know. Okay, so I'm going to draw a line from the center of this wheel out to the perimeter. So I'm going to label 3 points. So we're going to label this point A, we're going to label this point B, and then out here is point C. So imagine this bicycle wheel rotating, okay? The bicycle wheel is turning. What does points A, B, and C have in common? They will be moving with the same angular velocity. The angular velocity, if you draw a line, if you have something rotating in a circular path, and you draw a line from the center out to the edge of the circular path, every single point on that line is rotating with the same angular velocity. Now, why does that have to be true? Well, look, if you think about it, so point A is going around like this, point B is going around like this, and then point C is going around like that. Do all 3 points complete one revolution in the same time? Yeah. So the angular velocity has to be the same. Now, do all 3 points have the same tangential velocity? Meaning, like let's say you got a speck of dirt right here. If the speck of dirt flies off, boom, it's going to have a tangential velocity. If you had a speck of dirt right there, boom, it's going to fly off like that. Would all 3 points have the same tangential velocity? Or would they be different?
Oh, different.
They'd be different. Okay, now how do you understand this? Here's the way to understand it. If you think about it, which of these 3 points has a farther distance measured in meters? Which of the 3 points has a farther distance to travel? So here's point A. Point A goes around like this. Point B goes around like this. Point C goes all the way around like that. So which of those 3 travels the farthest? Point C, right? So it has a farther distance to go in the same time. Okay, so that brings me back to this equation. One way to find the tangential velocity, you take the angular velocity measured in radians per second and multiply by distance from the center. Notice that as the distance from the center gets bigger, the tangential velocity gets bigger. That make sense? Okay. Now, second equation, right here. So another way to get tangential velocity. So what do you notice about 2 pi r? 2 pi r is what? The circumference, and then capital T, this is a new term, so write this down. Capital T is referred to as the period. Now, what period is it's the time for one cycle, okay? Now, what has a period in physics? Or you're probably familiar with the biological period, okay? Boys? The boys probably don't know about this. But that's where the term comes from, right?
Cycles, right?
That's where the term comes from. That's a cycle, right? So in physics, what are the things that have a period in physics? What are the cyclical things that have a period? So rotational motion. So here's my bicycle wheel. Look. So focus on this little air nozzle right here. Here's a little air nozzle. So if this little air nozzle goes around one time, the time to do that is the period of the circular motion. Okay? Period is the time for one cycle. It pertains to circular motion. It pertains to a pendulum. Right here I have just a string with a mass. So look. Here is a pendulum. So later on we're going to talk about the period of a pendulum. What would be the period of a pendulum? Time for one complete there back. From here to there and back. That's the period. Mass on a spring. If you hang a mass on a spring and it starts to go doing, 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 the period is the time for one complete doing, doing, right? And then last one, anybody guess the last one? In physics?
Ball.
Not a ball. I mean, unless it were a pendulum. A wave. Okay, so if you're looking at a wave, so imagine like, you're sitting on a surfboard. Yo.
Can I take it like within
Sure. Yeah, you sit right there. So imagine like you're out in the water, like on a surfboard, and waves are going underneath you. You can feel the wave lifting you up and down. The period of the wave is going to be the time from one peak to the next peak, or one trough to the next trough. All right. So why does this equation work? Because I don't want you guys to just memorize this. I'd prefer if you understood it. Why does this work? What are you doing? You're taking the distance for one circle, right? So like look at point C right here. The distance that point C travels, divide by the time to do that. What's that going to come out in? Meters per second. That's your tangential velocity.